Another 10 G's. 10 grand for that. 360 watt panels. So that was showing that she would have learned base level penetration is like weird. More stuff. We're increasing right together. We're using like information just like we have on certain sheets. I didn't. It's pretty great. We try to like so I did that.
All right. Good morning, everyone. Let's go ahead and get started. I was starting 5 minutes late. I was just giving few minutes for people coming in with their new badges and all that stuff. I don't think there's anybody else, so we'll go ahead and get started. Okay. All right. Before we begin, there's a homework due next Tuesday. That's what somebody told me. Apparently it wasn't announced, but that's okay. No big deal. I've extended the date to next Saturday, so you can submit it next Saturday. Okay. So yeah, 1 week. It's for Monday? For your group, it's due on Monday? Well, I extended it for my class.
Someone slack Matt.
So
Someone slack Matt.
That's okay. No, don't slack him on his Saturday. Yeah. Let me see if I can. So we are in what? Let's see. So you guys are on this one. Course. All right. So for Monday class, I went ahead and extended yours also to next Saturday. So, all right.
Yes, who needs Matt?
So please let Matt know that I did this, so that you guys don't get into trouble.
Matt will be like, no, it's due on Tuesday.
Yeah,
Monday.
if he says it's due on Monday, then he will go back and change it. So that's your guys' thing to deal with, and then. All right, let's go ahead and get started. All right, so again, today, as usual, the week is more revision week. I didn't get topics, so today what I got was I'll go over basic Redux, and then there was a question that Alex posted, and people were interested to see how to solve it, or kind of look super weird and difficult. So we'll start with that. Okay. All right. So as I said, this is again, it's a revision week. It's optional. Well, it's not. The class is not optional. but the topics are more like optional topics. So if you think, and that's the option I gave my class also, if you think your project is deserves this time, please you can leave this class right now. Go outside, work on your project. I'm totally fine with it. Okay. You are here. You mark your attendance. It's all good. Okay. But if you are in the class, please don't have any project discussions. Right. The acoustics over here, they carry pretty well, and then it's hard for people to understand what's going on who are trying to actually sit in the class and learn some new material. Okay. Again, if you think I'm totally fine with it, you're not going to break my heart, you don't have to attend the class. If you think it's your project deserves more time and you can spend on it, please feel free. You can work on your project outside the class. Okay. The thing is, I'm supposed to give project time to the class, but what happens? My lectures kind of, I'm like talking, people are asking questions, kind of take more time. So again, we'll give a couple of minutes. If you want to work on your project, that's fine. But today I'm going to cover Redux, basic Redux, and then the question that Alex posted, so that everybody kind of know how to go about it.
Are we doing a project with Redux?
No, absolutely not. Please don't do your project with Redux.
Okay.
You said that we can, right?
Yeah. If you want, totally do it. But there's no use case that you would be using Redux. The thing is, people when they talk about React, Redux kind of comes naturally, kind of flows in. So that's why people were like, "Hey, I want to know what Redux is." That's why I'm going to give a brief introduction. You don't have to use Redux at all in your project, but I've usually seen one or two groups kind of try to use it. It's a good because it gives you like a application that you can work on. Otherwise, there's no use case that you would be using Redux in your code. Okay. All right. So the first thing is, did you guys see on hash random and saw that crazy question?
Yes.
Yeah. For those of you who didn't see, you can take a few minutes and look at it. For those of you see, did you guys like freak out? What's going on? What is this load balancer? I have like never seen this kind of thing. It is kind of it kind of throws you off in the first look, right? But as I was saying that we need to understand, we need to look past the description and kind of come to it what it is actually asking. The ask of this question is really simple. I know you would be like, what? How this so simple? It is actually pretty straightforward. The thing is that they have added so many words and so many things to kind of confuse you that kind of looks scary. Okay, anybody know what's the bottom line in this? What are they actually asking? What is it? What? You just say array? What do you mean?
That's
Array?
it. That's all I know.
That's-
That's all I teased out.
Well, that's the word over here too, somewhere.
Yeah, exactly. Teased out a word.
It's easy word. No. So what are they actually asking? Did somebody kind of decrypt it, kind of
Call
decode
back.
this? What is it?
Call back.
Callback. Yeah.
Okay, but could you kind of like show us like with your brain like if you
No, I'll go through it. Yeah. No. Okay,
How would you
I'll go through it. But I was asking if somebody else. Well, Alex is not here. I was going to ask her because she mentioned that she kind of decoded it and she was able to write the function. Yes.
I don't know. The pay request, it's like an array from like 0 to n minus 1,
Okay.
right? So, okay. So what, 3?
Three what? 3.
So k to n minus 1, 3.
Okay. Yes, 3.
And then the variable a will take whatever the number in seconds is, right?
Number in seconds. Yeah. And you are on the right path. But that's what the question is. But what I'm trying to understand is what is it actually asking? It has nothing to do with load balancer. It has nothing to do with incoming request and all that stuff that they have. Okay. Now I'll walk you through how you come to that. And again, if you guys think that I'm able to decode this just because I have more experience, then I will tell you that's wrong. That's not the case, right? If you talk to Alex, she said she was able to see through it and see what it is asking. Again, it has nothing to do with my experience of doing this. I don't do this daily at my work. I have never, I mean, you will never encounter something like that, right? All I'm doing is basically writing CRUD operations, creating APIs, some web pages, that's all. Okay? So these, how would you decode these questions? Like, how would you get better at decoding this? And other than object and callbacks, there is a third word that I keep hammering onto you guys. What do you have to do to get better at it? Practice. That's all. Guys, practice. You do enough questions that you see through it and you kind of see through the BS. Pardon my word. But that's you see through it. And again, it comes with practice. There's actually no other way to get through this question. Again, I have done enough. When I was working at Walmart, then I joined USA last year. So I took, that was like 6 years, and I accumulated so much. I won't say technical debt, but like an interview debt that when I started applying, I was like so shocked at how much the process has changed. Right from that onward, I have decided that I'm going to keep practicing every day. Maybe do like a one question, and that's what I do. I'm not looking for a job. Maybe I'm not interviewing. That's okay. But just to keep up with it, I go to lead code. I start with the easy ones, and just one day I just sit and I solve just one, and that's it. Just to be in the loop, right? And again, this will come from practice. Again, now, so coming back to this question. So if you look at the next screen, it's saying that there's a now let's go through the question. Like there's a load balancer. Basically, there's a server that's sending some requests, right? And when the requests come into the server, right, it has to process those requests. That's what it is saying. Okay. So the requests are coming in to this server, and then it has to somehow complete these requests. Okay. Now what it is saying is that this server doesn't have the capability to, if it takes one request and try to solve it, like it takes one, then processes it, then comes to this one, then comes to this one, there will be a lot of backlog. There will be accumulation. It's not feasible, right? So what it has decided is it's going to distribute these processes. It's going to give this to somebody else, this to somebody else, and this to somebody else. So like in server, they are called workers, right? So they're saying that's going to distribute the payload to its worker and say, hey, this request came in, you go ahead and work on this, and then this request comes in, it gives it to a second worker, this comes in, it gives you a third worker, right? That's usually how servers work. They kind of distribute the workload, and then they kind of come together and then say, oh, this has been completed. Okay, so by this case, what is it doing? It's dividing this work into different sections. Is that okay? Right? That's what the server is doing. It's dividing this payload into the work that comes in into 3 different sections. Well, it will come to the 3 part. And how many different sections it is distributing? 3 sections. That's what it says over here. That it's going to basically partition the work into 3 different workers. It's going to give this work to them. That's what this question is basically saying. Okay? Right. Any questions so far? This is how they are saying that the server comes in. Again, this comes with once you are learning more, you will see how the server works and all that stuff. Kind of how does it distribute? So that's kind of like the primary knowledge that they're saying. But that's again, you don't have to have that understanding to kind of solve this question. Okay. Now the first clue over here is this is the main part. They're saying find a write a function, right? Given an array A, as Blair pointed out, an array. That's the important part. So you are basically you have to write a function called solution that's going to get an array as an input. Okay. So far so good. Right now, what does that array has to do? Can I next? Okay. If you go through this, they're saying, okay, if this is your array, right? It has to basically divide this array into how many sections? 3 sections. Why? Because if you look at the previous one, I was saying it's kind of dividing this payload into 3 sections. Okay. So basically, this is your payload that is coming to your server, this array. Okay? And the point is you have to divide it into 3 sections. Okay? So basically what it boils down to is that you are given an array and you have to basically create subarrays. You have to divide this array into 3 parts. That's all you have to do. That is what the question is asking. That if you have an array 1, 2, 3, 4, 5, 6, 7, 8, 9, you have to divide this array into 3 sections. Okay, and we'll see that what is the criteria. How do you divide this array into 3 sections? But that is what this is asking, right? We'll see what it says. You can drop 2 requests and all that stuff. But basically, what it is saying is you're giving an array, and you have to divide it into 3 different subarrays. This kind of makes a little bit okay now. That okay, I have an array, and I have to divide it into 3 sections, right? Again, the point of this question is, they could have given you this question directly and say, hey, I'm going to give you an input array, and then based on some criteria that I'm going to tell you, you have to divide this array into 3 parts, right? This makes more sense. Well, okay, that's more reasonable. But that's not the purpose of this question. This question is testing not only your solution, this is testing how do you kind of evaluate the situation and kind of get to what you're trying to find. And this is important when you're trying to do debugging and all that stuff. You have an issue in your production, you're trying to find out, right? Now you have in your production you have a lot of code, right? How do you get to that point that is important, right? So this question is saying, okay, I have given you so much information which is redundant, which doesn't even matter to this question, but how do you get to the point where you're like, oh, basically what I have to do is I have an array, I have to divide it into 3 parts. That's what I have to do based on some criteria, and we'll see what the criteria is. Okay, this is the bottom. This is what the question is asking. Now let me go through what you have to do, and then I'll come back and see what questions we have. So let's use the array that they have over here. For example, what is it? 1, 3, 4, and then 3 2s. What is it? 1, 1, 2. Okay. So this is your input array, and you have to divide it into 3 sections in such a way that the sum of each section is equal to each other. That's it. That's what this is asking. Now, if I give you a question and say, hey, can you divide this array into 3 sub-arrays, right? Everybody understands sub-array, like small arrays, like 3 sections, right? Such that the sum of all 3 sections that you have chosen are equal. Okay, that's first part. Maybe I choose these 3, then I choose these 3, and then I choose these 3. Okay, and the sum of these 3 has to be equal. If that's the possibility, then your function should say true. If it doesn't fall through, then you say false. That's it. So basically, you have to divide your array in such a way that the sum of these 3 numbers is equal to one another. Okay? Questions? Yeah. What is it?
3 sections after however you pull them out.
No. You see this word contiguous somewhere? Where was it? Was it the previous one? Okay. So somewhere it says it has to be continuous. Consecutive task. Okay? So the numbers that you choose have to be right. You cannot change this array. You cannot modify. You cannot swap numbers or do anything. What you can do is you can choose maybe these 2, then these 4, then these 3. That's okay. You can choose these 4. You can choose this one and all this. The point is the sum has to be equal. Right? But you cannot switch, you cannot change the array. With this array, you have to find it. It kind of makes it actually easier versus swapping those numbers. Yes. Right.
Okay. Yeah. I have to. Yeah. So, but like, how you got to that just like looking at the question, right?
Yes.
Like the parts of the question that got you to that the
Right.
most are like,
It's this. I would say concentrate on the examples.
okay.
Once you read the first part, read it, you're good. I mean, you see these personally these numbers over here, these things. When I read it the first time, they actually don't. I have a difficult time understanding these things. When it says 0 to n, I'm more like a visual person, so I cannot see. I'm like 0 to n, 0 to k. It doesn't really make sense to me. So what I do is I read this once, kind of get the hang of it, and then when they start saying write a function, that's where I start concentrating. I say, okay, what do I need to do? Write a function solution. Okay, I need to write a function given an array a of n integers. Okay, so I'm going to get an array in my function, and that's when I'm saying, oh, okay. So it's kind of more simpler than what they're saying over here. They have a load balancer, server, and a lot of stuff. But eventually, what I have to do, I have to write a function to get points for this one. I have to write a function, right? And my function is going to get an array. That's it. Okay, so this is where I'm like, okay, at least this is a little bit better. That I can handle where I can write a function and I have array because I know enough programming. Okay, if I have an array, I have to do something over here. That's more feasible than all this thing, right? And here's the funny part: if you Google this thing, you will come up to load balancing algorithms and all this stuff. Unless you are interviewing for Google, it's probably going to be a more simpler, especially for a junior programmer role. They're not going to ask you about load balancing or something. That's the first thing.
That's what you think.
Now, well, unless you are applying to Google or Facebook, then then that's it.
Yeah.
It's changed.
Things are changing.
Things
Things
are
are like 20 years of experience.
All right. Yeah.
On everything.
Okay, the second thing is I look at the examples. Now I'm going to get an array. I know, and this is they're saying, oh, this is one example of an array. Now, if you look at this one, this is more readable. This you can understand better. Take a minute and see this one. This is more understandable. What they're saying is you get an array, okay, and then the function should. There's one more condition over there that I missed. What condition is that?
You drop 2 requests.
Hear that? So my server can drop 2 requests. What this means is, in my array, I can drop 2 numbers. Any 2 numbers, it doesn't matter. I can drop 2 numbers to make sure that I come to a section where there are 3 different sections with equal numbers.
It's not that you can, you have to, right?
You have to, yes. You have to. That's the second requirement of this question. That from this array, you have to delete or remove 2 numbers. Let's suppose I remove this number, and let's suppose I delete this number. Okay. After removing those 2 numbers, these are basically your anchor points. So the number that you are removing to the left of it should be equal to the center, should be equal to the right section. Okay, this is the wrong one that I chose. What's
The 2 to the left of the 1.
So-
the 4 is right. The 4 is right. It's
Oh,
the
4 is
2
right.
to the left of the 1.
which one is it?
The 2.
This
to
one?
the left. Yeah.
Okay. So you see, from the example, they're saying is this correct? Yeah. If I choose these 2 numbers, now you see, on the left of this number, the total is 4. On the center is 4, and then on the left is 4. So this should return true, saying, okay, this is the array that you can divide into 3 sections with equal sums. And that is what we are trying to do. And if you look at this example, this kind of explains the worker 2 and 5. So it's saying basically index number 0, 1, 2, and 5. That's the one that we chose. So everything after that or between that is equal. The sums are equal.
So the 3 sections were said in the previous slide,
Uh,
telling you that you have to do 3 sections. No, 3 sections.
Yeah, the 3 sections. Yeah, they are saying in the again, they are not saying 3 sections. We are coming to this thing by understanding what they're trying to do. If you look at the example, right? What are they saying in the example? You can drop request 2 and 5, which means this and this. How many sections are there? 1, 2, 3. That's how we are coming to it. What is it?
The gray is to indicate.
Gray is the one that we are dropping. Okay, so we have 1 section red, 1 blue, and 1 green. So that's how we have 3 sections. Okay?
It's like ACT.
So that's what they're saying. Again, look at the example that they're saying. Now you see the first example, they kind were more descriptive because the point is that by this you kind of have an idea what you have to do. I have to create an array with 3 sections basically, drop 2, and all those 3 should be equal, right? Then they kind of lessen, and then they say, oh, okay. The second example is just this. Do you understand why this would return false? Is there a way you can divide this into 3 sub arrays by dropping 2 numbers? By dropping, basically, it means you're not actually dropping, you are kind of making it an anchor. That, oh, this is the number that I choose, and this is the number I choose. So left of this and right of this, the sum is equal. Left of this and right of this, the sum is equal. That's basically. Now, if you have this array with how many numbers? 6 ones, is that possible? 1. Right? Is that possible? If I choose this one, right? There's no way. There's no way you can do it, right? So now you guys see, if they gave you the question saying, hey, you're going to get an input array, you can drop 2 numbers, or those will be the 2 anchor points, and you have to find the solution. If the left of this is equal to the center is equal to all the sum are equal. That makes more easier than, okay, well, this is something I can do. See, is that something you guys can do? I mean, you won't freak out as much. You'll be like, well, okay, I see.
Sound out what I would like to
Right.
do,
Yeah.
Right?
whether or not I'll be able to do it.
No, again, this is definitely simpler than reading through all this and kind of come to. That's the goal of this question. They're actually probably not even looking at your solution. They are saying, they are looking that if with all this, were you able to at least come to this solution or not? Well, Alex is here. Alex, how did you said you solved it, right?
Yeah, well, I think I did.
Is that the same conclusion that you came to? How did you come to this conclusion?
Yeah, so I was telling them to like, have your buddies, like, someone to talk it through it, because I freaked out when I first saw this question, not even gonna lie. Juan can attest to that. I was sitting there and I was like, what does that even mean? But then when I read through it and just talked it out, I was like, okay, so then what you have to do, and I said exactly that, if you have to drop this number and it has to be divisible by 3, and as long as it returns a remainder of 0, then it should be true. If not, it's false. And then it's like, oh, okay. And then from there, it became a lot easier to try to figure out how to write that up actually.
Yeah.
Talking it through was a huge help, like to figure out exactly what they were asking for, starting from the beginning of, okay, so this is where they started, like, what do I, it's like, kind of made me think of like math problems you have in high school or in college, like the word problems where they have all this extra words
Right.
and you just have to pull out what you actually.
Yes.
So, where was it that like you like I see it there, it says choosing request 2 and 5, but like it was on the first page where it's like kind of telling you need to drop
At the
those.
very end of
Like
the
what? Like how do you know
instructions for the
that?
function is the very
Okay.
bottom.
Okay.
So over here, they're not using the word drop. They are basically saying they're still talking in the terms of a load balancer.
Yeah.
So they're saying that you choose 2 requests, right, from a package of 9. Okay, so you can choose 2. It doesn't matter how many requests come in. Basically, they're saying you have to choose 2, and then those 2 they're designating as to be like the workers. Now we are talking in this term. So they're saying, oh, the 2 requests that come in, they are going to be responsible for everything else. So between the whole request that comes into our load balancer, our server is making a choice and designating 2 of these requests as a higher authority, as a worker who is responsible for kind of solving the other requests. That's what this is saying. So there it says, it's performed by selecting 2 requests that will be dropped. That's the word, and that will split the array into 3 contiguous parts. That's what Geoffrey you were asking. Where does it say it has to be 1 by 1, and that's what it says. Okay, so you have to pick 2, drop them, and to the right of them, to the left of them, and to the center, the sum should be equal. Okay. Any other questions? Again, this is going to come with practice. It's not that today you saw this and you're like, okay, I know it. You have to go through, do a different type of questions, and that's when you will see the pattern that what they're asking. So the last one says it's a length of 20,000. Do we start writing 20,000 numbers and try to solve it?
Get going.
Let's start. What is start with? 1, 2, 1. Let's start 1, 2, 1. Somebody keep a count until I reach.
So you read 20,000?
Right?
Oh wow. Okay. Still got quite a bit to go.
Right? I'm not going to write this out. So how do I condense this? You see, there's a pattern. Starts with a 1. It's 1, 2, 1, 2, and it ends with a 2. Right? Pick any number of array. Pick a 10 or a 8 and solve for that. And it should solve this for all of them. So let's pick one that actually gives me a solution. 2, 4, 6, 8. Let's try this one. If I'm looking at that, will that give me a solution? Will that return a true or a false? I have true, right? And why is that? Which ones? Where is the anchor? This one? And then this one. Okay, do you see it? Right? Again, and then if you want to make sure, add one more where the case kind of fails. So if I add one more, will this return a true or a false? Still true? Oh. How's it true? Is it true?
The problem said it should be true, so I was just.
No problem. It's at 20,000. What is it?
Oh, specifically 20,000. I thought it meant anything.
Yeah, we can solve a 20. So we are trying to make sure that our algorithm runs for a case where it fails and where it passes and where it fails. I think it failed, but somebody said that it's successful. How is it successful? Okay, because we'll see how we solve it, but you can't have an equal sum. If you choose this one, it's 3. Choose this one is out of order. We choose this one becomes 2, 4. This one becomes 5. There's no possibility, and then this one. So this one is returning false, and this one is returning true. So even if you kind of condense it, why? Because in the middle is going to be 1, 2. We 100% know this, right? There's no different pattern. So pick a number that you think is going to succeed and find the one that's going to fail, and then run your test against these two. If it works, then this one is going to work for 20,000. Right? You don't have to write for 20,000 numbers. Okay. All right. Now do you guys see? Now the problem is you have an input array. Okay. Of some numbers, any numbers. Right? How big the array could be from 5 to 100,000. Again, we don't have to test for 1 year, but you see this 5 is important. Why does it say 5?
Because you can't have 3 words so small.
Right? If anything, if your array size is less than 5, you cannot have a solution. There's no possible solution ever. So if you have a 4, you can never divide this array into 2. There won't be a solution. If I choose this and this, then it's 1 and 2, and there's nothing in the array, right? So your minimum size has to be 5. If it's 3, then there's no anchor at all. If it's 2, 1, nothing. Okay? So the minimum is 5. Remember this. When you're writing your algorithm, they're going to check if you get an array with less than 5. What happens is your algorithm kind of fails and be like, oh, I don't know what to do with it, right? Or you have a check over there that if it is less than 5, you error out, or you say, oh, false. By default, you don't even go through the whole thing, right? The first time you say, oh, if it's less than 5, I'm not going to do anything else, so return false. That's why this is important. Okay? So again, these are our test cases. Now the problem is that I'm going to give you an input array. You have to have 2 anchor points. These are the points that are going to decide the array on the sum on the left is equal to the sum on the right, and then sum on the center. Is that more understandable now? Okay. Can somebody come up with a algorithm? Take a few minutes, think about it. How would you go about it? Well, now it's again, it's not again, the algorithm part is, I'm not saying it's easy, but now the problem kind of looks a little bit easier than this one. Right? This is we have learned, we have the programming skills to kind of find this out. Right? This I can understand that it's confusing and all that, but if I break it down, then we should be able to at least start on it. Matt, you want to give it a try?
Just an algorithm that does it.
Like I don't. I'm not even coding part. Now, before you write the code, I want to. How would I go about it?
So I would do a loop within a loop to pick my two that I'm throwing out.
Okay, let's start with the first one. Okay, so you're going to do what?
So I would do a loop from I is index 1 through length minus 3, testing out what I'm going to be using as the first one I chose.
Okay, so what I understand, Matt is saying he's going to start his index from where?
1 to
1 to?
a array length minus 3, I think.
Okay, so array length minus 3. Everybody understand this part, right? We are like pseudocoding right now. So this is my array.length gives me how much? 9. 9 minus 3, 6. So he's saying start from index number 1 and go up to 0, 1, 2, 3, 4, 5, 6. Okay?
Actually, it might be minus 4.
Minus 4. Okay?
And then I would move through again to pick the second one called J.
Okay, so J
From I plus 2 to array length minus 2.
Okay. So even before you explain this, can you visualize what are you trying to do? Just explain that what are you and what is the goal of this? It's kind of hard to see.
So I want to loop through the array and starting with the lowest number that the first one I throw out can be, which
the worst number that you can throw. Okay.
which would be index 1, because I can't throw this one out because then
Yes.
there'd be no array to the left.
Okay, makes sense.
And then once I'm testing this one, I got to pick the second one I'm going to throw out, which has to be at least 2 more than I, because I have to leave something in between.
Okay.
But then it can't be at the very end. Minus 2, right?
Okay.
It can't be the last one. It has to be something.
So you are always starting from the second index, which is 0, 1 index, right? Second number.
Right.
And then you choose a number that is 3 ahead. How many indexes is it ahead?
At least 2.
At least 2. Okay, so you'll pick 2.
Because it can't be here because then there'd be nothing between them.
Okay,
I have
so
that middle
okay, so for this input we chose 3 and then we chose 2, right?
Right. So if it gets to that point, so every time it picks 2 of these, then I want to add up the subarray that's the array less than I, and then the subarray that's greater than I less than j for the indexes, and then everything that's greater than j, and see if they're all equal.
Okay, but will you be able to do in the same in this loop? Because this loop won't complete until this is complete. So you're going to go through this whole thing, and then come back to the second one, and then it will run this loop for this index. So you don't have access to. You see what I mean? It's going, the inner loop is going to complete first before it can come back to the outer loop.
Right. So first I say I is going to be 3.
Yeah.
And then let's try every possible j with I being 3.
Okay.
And test those arrays, see if any of them work. And if none of them do, then let's move I up to here.
Okay.
And then try all the j's based on that. It's kind of brute force. I don't think that would
No, well, I mean it's a good starting point.
And
So
so I stays in one place for a while all the possible J's are
oh,
trying.
I see. Okay.
And then if none of them work, let's go back and try the next die.
Okay.
And then all the possible
So keep going forward. I think I see what you're saying. So now how do you sum them? So remember we have to know the center also, left, right, and center.
Mhm.
Okay. So let's start with, you can remove these anchor points. Looking at 4 here. 4 and 2. Okay. Just write 4 and 2, and then start here. So your algorithm starts from 3, right?
Mhm.
The number 3 and then number 2. So this is your I, and this is your J. Okay.
J. We'll
Okay.
try that out.
Okay. So now go ahead. How do you add? How do you test if this is the right answer or not? How do you sum them up now?
So I filtered the array using the exact stuff we needed, or do another loop to add up.
Okay. Go ahead.
what's in
Yeah.
the array.
Okay. Let's try the loop adding what you're saying.
Um,
Okay. So he started from the start to the end of the array, I minus 1. Okay. I is, wait, well, I minus 1 from 0 to 0. Okay. So it's going to just pick the first one.
right. Yeah.
Okay.
This case
And then
it's
it adds it. Okay. So
And
that's
then
my
start-
left.
array 1 is 0, and then we add.
Yeah.
whatever next to
Okay.
that.
So now I have my sum on the left, right?
Mhm.
Okay. Now I need sum on the center. So let's see, I plus 1. Okay, so you are calculating the center. So this for I equal to I plus 1, this solves the center one, right?
Right.
Okay. And this goes all the way to the left and adds them up. Okay. So now I have 3 sums. And what if it fails? Well, because this is not the solution, right? Now what do you do?
So it,
So you came here, you take these two and you added, so you got the result in A1 as 1, then you got 4, and then over here you got 4, 5, 6, 7, 8, right? This condition kind of fails.
right.
Now what do you do?
There'll be some success condition that's false, and this will set it to true. If it works, if it doesn't, it just keeps going through the loop.
So it will come back over here.
right. It'll just,
Okay, so
well,
now,
it'll actually come back to all of those. And then eventually come back here. just gotta try all the J's before it goes to the next I.
Okay. So I think this was just one. Now when it comes to this one, what's going to be the next?
We'll have this move J over here.
So this iteration is good. I like this. I mean, this will work for this condition. But how do I? So I was 1, right, and 1, and we started from here. Right. The next is your J is going to start over here, but your anchor is, where's your anchor? This is your anchor, right? That you're saying you
I and
want to
J
draw?
are 2.
Okay, so how do you move? So what's the next? So this is going to be your anchor.
Yeah, so if this fails and kicks out, it goes back to the next thing, the J would move the anchor over 1.
Okay.
And then it tries these 3 arrays again. And if that fails, it moves J again.
Okay.
And then if J finishes, none of them work. Now
Okay.
I moves over. And
Okay.
J starts here. And goes,
Okay. Okay. Do you guys see it? I know it's a brute force one, but it's a good start. I mean, there are like how many loops are there? 1, 2, 3, 4, 5 loops. Usually more than 2. I mean, 2 is considered. They will ask you to refactor if there are only 2 loops. Forget about 5. We won't even go there. But that's a good. So you guys see what he's saying? He starts from here and he puts them. He evaluates the whole array, then comes back, moves the anchor, then evaluate. Eventually, he will come to a conclusion where both right and left are kind of same. Anybody else has a different one? What is it? How can we improve upon this? I mean, it's a good start and it will work, but it's not an efficient solution because you have like 5 ones. How can we improve it? Do you have an idea? Okay, go ahead.
Because there's that method to remove the first item in an array, right? And then there's the method to remove the last item in an array. But is there one to remove something in the middle?
Now let's not go with the array removing one, because again they are saying you have to drop it,
Yeah.
but basically the point over here, you see over here, you're not deleting any numbers. You're not supposed to delete it. Yeah, there's no removing. They're saying drop it, but as I said, you're not able. Forget about the array functions. Other than the array functions, how do we solve it?
I don't I don't understand what you mean by dropping it but not removing it.
No, by dropping I mean is that these are basically your anchor points. The solution,
Okay.
when you add these numbers, it's not going to include the addition of this, right? For example, if my solution for this one, what's my solution is 4 and 2, right? This and this is my solution. So basically, when you're summing, you're not adding these numbers in the sum. You're saying, oh, number to this 4, 4, 4. So you're kind of ignoring. You're not adding them to the sum. That's what it means.
Yeah, so you're not actually dropping them.
Yeah. Again, that's the term that we need to understand, that the dropping is for the load balancer stuff. It's not actually for the array. The array basically is saying that you have to choose 2, right? And then to the left and the right, it has to be the same sum. That's what it is.
So kind of just ignore the whole first page.
Basically. That's what I said, right? Read it once and then find out what actually you're trying to do. Yeah, the first stuff is basically you can ignore it. Now do you have a different algorithm? No? Alex, what did you come up with?
I did for loop for it.
Yeah, please. You can write it on this side.
So because you need to be able to find all of the numbers, I think that's kind of what I did differently from what everybody else is saying. Is instead of dividing this by 3 and this by 3 and this by 3, I added all of that up and then divided it by 3. So what I did was I put it inside of one function though, so divide.
You're up next, Blair.
Oh, God. I don't even know I'll be up there.
Well, at least come up with a what do you? They both are in the right direction. We can just make it more better, but it's kind of similar to it. Well, I'm looking at her. I'm not sure.
Let's let Alex finish. I think she got it right.
Yeah. Okay. So if I is not equal to 2. Oh, okay. Let's see. Yeah, plus equal.
Yeah, okay.
Or you can just say sum equal to sum plus.
Okay.
Yeah, you
I
can.
think
You
I
can.
think I did it like that.
Yeah, yeah.
And then,
Okay, yeah. So stop it. So what are you? I understand. So that you guys understand the if condition. If condition is for this index, it shouldn't be less than 5 or number. So that's okay. What? So now you're adding the whole array. This thing. This whole thing.
Yes.
So 1 plus 3 plus 4
Yeah.
plus 2. Okay. What's
And then-
what does it come to?
and then you return. I don't remember exactly.
So it says
So
4.
is she nesting the if in the 4? Because you got to close off at the 4 here.
Yeah. She's going.
Oh,
It's
yeah.
inside it. That's okay.
Yeah.
Yeah.
Okay.
It's inside it. You can even ignore. You can even ignore the if right now. And the reason is because she's just testing if this is less than 5 or not. We will go with the assumption that we will never get an array that's less than 5. So we can ignore. The important part is she's adding the numbers up.
Yeah.
So what's
you're
the-
everything.
What's the addition of this? 4, 8, 10, 12, 14, 15, 16,
And then
18? Is that the right answer?
Huh?
So you
Oh,
are
this
summing
one?
this up and
Yeah.
it comes to 18?
yeah, and then
Okay.
you would return. Return. It would be the 3. How do you write it? I did Google this. I'm not even gonna lie. They let you Google things. By the way.
Yeah.
Percent size.
Oh,
We are
yeah.
trying to understand the logic. Okay, so you are
Equals
That's what I was thinking.
0, and then you closed it off because if it would, you ask it to return the remainder equals 0, then it would automatically come back true or false. Is what it did for me.
okay. So in this case, the answer is 18. So 18 is divisible by 3, and then you return and you say
It would be true.
it will be true. What about the 2-1 case?
The 2-1 case, I don't know. It automatically ran it through that because.
2-1. Does it work for this one?
Mm-hmm. Yeah.
Wait.
Because these test.
No. Here. So the first one, if you add these numbers,
yeah,
these
it was
come to
false.
6. But 6 is divisible by 3. So your algorithm is going to return true.
But it returned false because I took out. I don't know. This is how I did it with this. I thought.
You must have dropped two numbers in your
Oh, so she's dropping. So the if condition is actually
I was gonna say,
dropping
isn't it? Yeah.
2 and 5.
Drop it there. Yeah.
Oh, okay. So
So
you are
take
kind
those
of
out, then sum it, then return the remainder.
okay. So this will always drop number 2 and number 5, no
Yes.
matter how big the array is.
Yes.
But then it should fail in this one. 2.
In the example that they gave, which is this one, this is the one that they run with the length of 20,000. It returned
Yeah.
true.
Dropping 2 and 5.
So if you drop 0, 1, 2, 3, 4, 5. 0, 1, 2.
Oh, in that one it returns false
5.
because if you drop this one and this one, you
Oh.
can't. They're not divisible by 3.
Okay, and then
And in the
in this case, if it's so it's 0, 1, 2. So you drop this one, and then 3, 4, 5. You drop this one. So
Are you just
it's
testing
2, 3, 2.
one specific condition?
So you're just
Yeah.
yeah 3, 3, 3. So that one would be true. And in the 20,000 one, it worked. I did get a thing saying that this was not the most efficient way to do it because it told me my runtime was really long
Right.
on the length of 20,000.
Yes, and To be honest, I'm actually not even sure how this is working because but it's correct to the input and it's always going to work for the input because you are. But you see the problem where you are always dropping the this and this. So if it's a bigger array, right? It's always just going to drop this one.
I thought that's what it was supposed to do.
No. This is in this example. It says you can drop 2 and 5, but it's not true for every example.
Oh, I thought on the first page it
They do use the number 2 and 5 quite a bit.
Right. And because they're saying that the requests, if there are 9 requests, they're giving an example over here.
And then if you look at the instructions.
Right. So this this algorithm luckily works for these 3 examples because in this case the solution is that you have to drop 2 and 5, but eventually you'll run into this. I'm actually surprised that it's even running for 20,000 because if you drop second request and fifth request from 20,000, there's no. I mean, you're calculating it wrong, right? If you drop between 20,000 and this, it returns false for a different reason. But within 20,000, you stopped over here, and you just said, oh, it's false.
I thought it was true, but yeah.
Huh?
That
No,
one's true.
20,000 returns false, right? Oh,
True.
where is it?
True.
Oh, okay. So I'm not sure how do you think it's returning true? Because you stop over here.
Because it's
Well,
divisible by
it's-
3.
yeah,
That's
it's
what
still
they
divisible.
Oh, that's divisible by 3. Okay, I see it. Okay. Yeah.
I originally did not start it with this. I originally started with a dot filter dot reduce. That was the way I first did
Okay.
it, but I was running into some issues with that, like with runtime again. So then
Okay.
I switched it to
Yeah.
sort of like this. It looked much better.
Right. Again, it did say the runtime issue, but I think that it might there will be some condition where this is going to fail. And do you see why? Because
Yeah.
we're kind of hard coding. It's always going to be the second request that we are going to drop, and it's always going to be the fifth one that we are going to drop. But there might be numbers where these two are not, but it actually is this and this that we have to drop, and that's where this will fail. But I mean, you got through all these 3 and you passed it, so that's good.
Yeah.
All right.
It was really interesting because like Juan was like, oh, you should tell them. So the first question I had was actually a React question.
Okay.
It was so the position that I guess I got put up for was a React Node.js position, and so my first question was a React question where they just had me do a simple click counter, where you just create a component for a click counter. But the thing that they kind of try to trick you on is that they want you to use specific class names and different things like that.
Okay.
So they want you to use they want you to label it a specific thing, or the button ID has to have the specific thing. So I think that was what they were trying to see, like how much you were paying attention.
Okay.
Also, had a mild panic attack. I was like, I don't know how to do that, and Juan was like, Yeah, you do. But then my third question was actually 10 multiple choice questions, all about Git, and 5 of the questions were on rebase, which we have never gone over.
Right.
So,
I try to stay away from rebase.
yeah, so I was like, okay, but yeah.
Okay.
That was how I did that one.
All right.
It worked in every test case I
Yeah.
did,
It
and every
works
test
for.
case they said, so
It works.
worked.
Yeah. It works. Thank you. So it does work for this thing, but well, anything else? A little bit more like a full proof that it's always going to work. All right. Anybody? Where's my? Anybody else has any other idea? This is still better because we're not hard coding 2 and 5. So this, but it's an improvement to this method.
You know how many catch the processor on fire?
Give me those numbers again. Alright, so it's 1, 3, 4, 2, 2, and 1, 1, 2. Alright, I'm going to. Anybody else has any other idea? Or I'll show what I think. I don't think it's most efficient, but I'll show you the solution and then you guys kind of build on it. Anybody else any other idea? No? So what I came up with is that you start, in this case, like Matt was selecting two indexes and anchors. I'm kind of going through the same approach. But what I do is I start from the end and here. This is what I say. From when my array begins, the parsing begins, I choose 2 pointers. I say the first anchor is going to be this, and my second anchor is going to be this. Okay? When my array starts. And then what I do is I check the sum of left and right. I'm not worried about center right now, right? So I'm going to start from here. I'm going to say, oh, what's to my left? The sum is 1, right? And to my right, the sum is 2, okay? So whichever side the sum is less, you move the anchor to the next element. So over here, the sum is less, so I need more numbers over here, right? So what I do is I take my anchor, I keep this same, and in this case, I move my anchor to the next one. So I move it to 4. Okay, now my sum is, yes.
Well, isn't this like the quick sort? Kind of, just like that you have anchors.
Yeah, okay. So don't worry about the word anchor. What I'm trying to say is I'm picking the number that I need to drop, basically, that I need to ignore. But again, don't. It's a quick sort is mostly like sorting the algorithms, right? This is not sorting. It's parsing. Okay, we'll come to that. So now my index. This is 4. This is 2. Now which one is less? This side is less. So I need to move my anchor to this side. Okay. So I go ahead and then I move my anchor to 1, and this goes away. Now my total is 3 on this side, and do you have the numbers correct? Because this is the solution, right?
Yeah, this will work.
Okay. All right. So I have my 4 over here and 3 on this side. Still, this one is less. So which one? I need to move this. Still, keep moving this further. So I go ahead and I move this over here. Now my total becomes 4. Okay. Now this is a case where I'm like, oh, my sum on the left is equal to my sum on the right. Now this is the one condition has met. Now I need to see if the sum in the middle is also equal to one of them. So what do I do now? I stop these 2 anchors. Then I check that. I write a for loop which starts from here and then goes up to here and then creates a sum. In the end, it gives me a sum of the numbers that are between 2 anchors. Alright, now I get 4, that's when I compare. You can pick anyone, you can compare it with the left or the right, pick one, it doesn't matter because these 2 are equal anyway, right? We have already tested. Now I compare these 2, if this is matches, then I say, okay, this is the solution, and then you exit out. Okay, now let's run this with the next case, which is a little bit more trickier, the 2-1-1. 6, 7, 8. Right? This is the solution. Let's follow this along. Right? Where do I start? I start here, and then I start here. Right? This is 2, and this is 1. This is the anchor that I need to move because this is, this is the one that I need to move because this is less. Right? So I move it over here, and this becomes 3. I compare them, this is less, so I need to move this anchor now. So I move this over here, and this becomes 3. Okay? Now both of them are equal. Which index do I need to select? These indexes. Okay? Write a for loop starting from here and here, add them up, and then I compare and then say, okay, this matches, this is okay. Right? Similar to this one, the one that fails. 2, 1, 2, 1. So 6, 7, 8. 8 works, but this one should fail. Same thing. Start from here. 2 and 1. So which index am I moving? Which pivot? Which anchor?
The right one.
Right one, right? So I come here, and this becomes 3. Now which one? This one, right? So I move this, and this becomes 3. Now both are equal, right? My sums on the left and the right are equal. I start my for loop from here to here. What's the sum? 6. This is a condition where it doesn't matches. Okay? So I'm like, okay, so these two are not the correct anchors, right? But do I stop over here? I still have ways to go, so I cannot stop over here. The only thing is, these are not the correct anchors. Okay? So if, in this case, when this number fails, what do I do? Which anchor? Now both anchors are equal. Which anchor do I need to move?
Can we assume that there aren't zeros?
Yeah. So there's 1, 2.
Yeah,
No.
1, 2.
Then move both.
Huh?
Then move them both.
Then move them both. Excellent. Both are equal. So we know now we were moving. If one was left, we move the other one. Right? In this case, both are equal. So what we do? We move both of them. And this is the only case when the sums are equal. Now what happens? So this is 5 and this is 4. Okay. Now which one do I need to move? This one, right? So this one goes to 1 and the total becomes 6. Okay, now this one. So what is the total now? 6 again.
Shouldn't you fail out before you move it?
Why?
Because the two are touching. They have to have something between them.
Oh yeah. But I reached to this position just now.
Right.
Yeah, now I'm going to test the condition and then I'm
Oh, test
yes.
that.
Yeah. I moved it because they were equal, and then I'm going to say okay, and then see if they both are equal or not. Yeah, I see what you mean. We'll get there. Now these both are equal. Now I need to check if this is there. Okay. Now between them there is nothing. It returns me nothing. You can keep continuing. For this case, it's going to return me a sum of 0, right? Because there is nothing over here, right? So since these don't match, what I do is I keep going forward. Okay. Same condition. If both are equal, what do? I increase the both anchors. Okay. So when I increase my anchor, let's suppose this is my left and this is my right one. When I increase this, what happens? This comes over here, and then my left one kind of crosses over. Okay? And this is my stopping condition. As soon as they cross over, I'm going to have a condition where my left is always less than my right, the index number. As soon as this condition becomes false, I'm going to exit out, and I'm going to say, oh, there's no possible way that it will come to a solution.
Oh, okay.
Okay? So you keep going until you hit this condition. My condition is my left should be less than my right. The index number, not the sum, the index number. Okay? As soon as they cross over, or they're equal also, it's going to exit out, because this is checking only less than. It's not going to check your equal to condition also.
Why wouldn't you stop one step earlier when left is only one less than right?
When left is what?
Because as soon as left gets within one of right, you know it can't work, right? Because there's no middle, right?
Yeah, you can write it. But again, this is when you're writing the code, where would you put that condition? That's where it comes. If you're able to squeeze that in, then yes, go ahead and write it. But this,
The extra code is going to run a little bit longer too, right?
well, we have to see if you can, put that condition, because this is all, it's going flow for every condition. Right now we came across this. There might be a condition where there's just one number in the middle, right? But that's also not a possibility. Well, it could be if it's a bigger number, right? But again, that's a good condition. You can stop over there. Once you write the code and see if you can stop over there, then that will also work if that's possible.
I have a question here.
Yes.
So this is almost like when you identifying median. So you have to have a even array, right?
No.
In this condition, because if you
There's no. It doesn't have to be an even array.
even number on like.
No, so why would it have? Again, we are not dividing. We are adding.
When you're going right, so in order to reach not the middle number, which would be one that condition, then it has to be even, because then you have to cross.
Yeah, that's and my condition over here is
And
going
that's
to
what I was
stop.
saying. So it has to be if you want to reach, the drawing, and then there's nothing in the middle. That means that has to be even.
No,
Right,
no.
right.
No, it doesn't have to be. My condition over here, if it crosses over, it's going to stop it over here. At some point, it's going to cross over, even if it's an odd number array or an even number array. It's going to cross over at some point.
Oh, because you're not moving it evenly. Okay.
Yeah, I'm not
okay,
moving
okay,
it even.
yeah,
So it's going to
okay.
cross over at
Okay,
some point,
yes, yes.
and that's the point that I'm going to stop.
Okay, so it doesn't go. That has to be
Yeah.
more. Okay.
Okay, do you guys see how this will work? Can somebody write the algorithm? Sketch it out on the board. You can? There. So these are my starting points, and then I'm kind of going to the next one and comparing. It's not as difficult. Kyle?
Two variables and it sounds like based on
Gonna give it a try. Write it on the whiteboard. It's not. It's not. This was the difficult part. How do you come to it? Now you guys, I see some of people are like, oh, okay, kind of makes sense. Writing this code is not. It's not difficult. Yeah, you are just. You are just going through the array, starting from starting and end, and then you're just adding those two numbers.
so taking so it's gonna be the input.
So array 1 gives you the value, right?
Yeah.
Okay, that's what you're going for. Okay.
Well,
So we are going through the indexes. So you need the index first.
yeah,
So just
remember what it is.
just one. You don't need the array. If you assign left is equal to 1, that's the
Yeah.
index number that is going to start from, right? Yeah. And my end index is going to be?
And it's going to be
How do I get my
so
last to
length.
1 before index?
Well, so I'm thinking like index dot. So you do the length, right?
Yes. So array.len.
Yeah.
Yep. You can say A, that's fine. We understand. A dot len and then
Length, and then you have minus 1, right?
minus 1.
Would be
Yes.
minus 2.
So the length is this one. Y minus 2, I guess.
Yes, minus 2. Okay. So this is how you start the anchors. Alright, you guys see this is how you when I describe it looks difficult, but this is simple. You are starting index 1 and 1 index before. Now you have your 2 pointers. Okay?
So
You actually don't need even a for loop here.
you don't.
Why? Remember the conditions? When are we increasing and decreasing? When the sums are equal, right?
Correct.
So
When
let's
they're not
start with
equal.
the condition.
So if
Let's start with the sum is less than the left one. The sum on the left is less than sum on the right.
so you would do it in if condition though, right?
Yeah, we need a condition, but not for loop. We need a while one, but right now it's not as important because we are not looping through the array anymore.
Yeah, but how do we get
Okay, write it out and we will see. So sum on the left, right? Yeah, sum L is less than sum right. Okay, everybody see this condition that I'm comparing the left and the right, right? Then I have to do something. Now, before even you start, how do you get the sum on the left initially? What's the sum on the left when even before I compare? So what is
Index zero.
It's,
index 0? Yeah, that's my sum. So I can hard code on the top saying my sum on the left is always going to be at index 0.
So you insert it into the variables.
Yeah, create another variable on the top. You can create on the right side, so you will understand. Yeah, somewhere here. So you are saying sum on the left. Yeah, sum L is going to be at array index 0. So A,
Yeah.
okay? A and square bracket 0. Right? That's always going to be my starting point. What's my sum on the right with the same logic?
It's gonna be
Length minus one.
Length minus 1, yeah. Okay? So now my sum on the left is 2 and sum on the right is 1. You see it, Kyle?
Yeah.
Okay? Now that's a good start. Now we compare those two. And now let's go ahead and do it. So if the sum on the left is, what is the sum on the left right now? It's 2. And on the right it is 1.
Yeah, we're looking at this one.
Right? So let's write the second condition because this condition is not true. So else if sum on the left is greater than sum on the right, what happens then?
You need to move the
Yes.
index.
Yep.
So then
How do you move the
moves-
index?
So you just add 1 to
Exactly.
the value.
Yep.
So
Are we moving
How are you moving what?
I thought we were moving the right.
Yeah, he's writing the second condition. The first one is not true over here, right? If sum is less than sum right. So we,
add.
Huh?
But he said add.
so
so what's the condition right now when our array begins? Our sum on the left is actually greater than sum on the left, right? So he's writing the condition where sum left is greater than sum right. Sum left is greater than sum right. Okay, now what do? We have to move the right index. And what is our right index is,
R plus plus, right?
oh, r plus plus. Right. What happens when you do r plus plus?
It's adding.
Right? It
So-
goes towards the right. We are trying to move it to the left.
So minus.
Minus. There you go. Okay?
So then, yeah, so then you need that.
Okay, and then you need to, since you move the anchor, the sum is also going to be updated now, right?
Correct.
So, what do? You already have sum on the right. You add the new value to sum right. Right, so sum right now has 1. So you will do plus equal to, and then whatever the new index is. Which is
R, right?
yes, R. So it's going to be array
Plus one.
square R.
The new index we're adding to.
Right. Y plus 1. So R is n. We are trying to move like this. We're going this way.
But we already moved it, so aren't we adding R plus one?
In what case? Oh, you're saying the statement should be after? Yes.
Well, either flip the statement
Yes.
and change it to R plus
Yes.
one, right?
No. Don't change it to R. Move R minus 1 is at the bottom. So move R minus 1 after you do the sum. So what he's saying is if you already calculate this first, you're going to get the wrong index. So put the sum before, add this to the sum, and then move R minus 1. Yeah. You can actually do it in one line also, but yep. And then in the next line you would do R minus 1. So now you're moving towards the.
So then that would.
That's it. Yeah, we haven't met a condition where both are equal. That's why we came in this condition.
So left is less than right. That's greater. So this will be the equal.
Yes, this will be the equal. Well, you don't have to solve that right now because this condition is met now. If we can follow through the code, like on the top. So if you have moved the anchor, right?
Yeah.
It'll be easier if you follow through. So right now this condition is done. So now next round comes along. So our anchor has moved from the top. If you look at this part, this area, so we started over here, right? So you can remove this, and then we started here. We started there, then it kind of moved over. So it's now 3 and 2, right?
Sure.
So if it is 2 over here and 3 over here, this is the condition that we come to. So we write the code for this one. If your left is less than your right. So if you're same thing that you did on the yes.
And so then left is plus. Right.
Yep, same thing. While you are increasing the left one, yep, that will work. All right. So that will take you to left and right, and the only thing remaining now is the center one. That if it is equal, then you have to write a for loop and come to that.
Yeah, but, okay. So this is where I get tripped up on it
Okay.
because so it's using for each.
That's okay. Well, you can't use for each over because you have to pass an array and 2 indexes. For each kind of loops through everything. It doesn't matter, but this time we are kind of we have to do like indexes that from this index to this index, right? So you will say for k is equal to our starting index would be left plus 1. So it's going to be L plus 1 because we are trying to loop from here to here, right? L plus 1, and the ending condition would be my right index. Right? So I'm trying to run from my left index over here, this position to this position. This position is R. So you will say L plus 1 to R. And then you just add them up, like sum is equal to, let me see, written is 50. But you're almost there. That's okay. You can. The outpost. Outpost. Solution. Solution. Yes. Kind of.
They're multitasking.
Okay. Now, again, I'll post the solution. Actually, let me quickly show you. Do I have it? I don't know if I have it. I think I have it. Let me. It's not. So this is the same thing that just Kyle kind of coded it out. Same thing. Left, right, going through. These are the conditions that are mapped to it. That's the solution that I came up with. Again, if look at it, if you guys can come up with a better solution, please let me know. Because still using the while loop over here and then kind of loop through the center ones, right? Still, it's I don't think it's the most efficient one, but I don't know. In the first go, this is what I came up with. I had a chance to go back and see, but if somebody else comes with a better solution, I would really love to see how to make it more efficient. But this solution is foolproof in the way that it's going to work for every possible input that they give you. Okay, it doesn't kind of hard code the anchors, or it doesn't have as many for loops also. So this is the one that he coded. Yes. This one? This one or this one? It's on hash random. She posted it. You can see that. Yes.
Could you take out of it the inner array that turns out to already be smaller than the outer one?
Yeah, I have on the first line. Oh, if it's smaller than the.
Because it's just going to keep shrinking. So
Well, no, you don't know because it could be a higher number. It could be like 10, which kind of equivalents to everything. These numbers, it can be anything, right?
Right.
So if even if there's only one space in between and the number is so high that it kind of equates.
Wait, no, I know it's possible, but I'm saying the sum in the inner array, like left and right match.
Yes.
Now we check the middle one.
Oh yeah.
If the middle one's already smaller than left and right, there's no point in going in anymore because it's just going to keep shrinking.
No. How do you know that? It's not sorted. It's if
Because
these.
it's a sum of all those numbers. If we move in, that sum goes down.
Oh, I see. Because there's no possibility if the sum is. That's a good one.
Right?
Yeah.
Unless there was negative numbers in it, it has to see a shrinking, right?
Yeah, that's a good one. Oh, okay. So that's we already making it more efficient. So if it is never true, you can skip it out instead of so if this fails, where would that be? This equal to so over here we already have this sum. He's saying if we check if the sum is less than, then there's like no possibility. So you can actually skip from here. Yeah, you can break that too. So see, you guys are already making it more efficient. You don't have to go through the whole thing. Okay. Again, give it a try on your own, and I'll post the solution. You guys can look at it, but this is the main algorithm. I hope kind of a little bit makes sense. This is why I went through this. These are kind of questions that, again, they come through more like a practice. Okay. Again, as I said, I'm trying to get into a habit of doing one problem from lead code every day, just so that I am updated to the interview questions, so that I don't have to accumulate 6 years of interview prep in like one day.
One problem from what?
Leadcode.com. Yeah, you can sort by easy and start by doing the easy ones, and then come up to the difficult ones. Right? This I would say is still like a medium. It's still like between easy and medium. This now, if you see this solution, right, it's not as difficult, but the wording kind of makes it more medium. But I would still say they might consider this as like an easy one. Okay. Any questions? I'll post the solution. I hope this was beneficial, and you guys can see what you are, what is expected. Oops. Brandon posted a solution as well. Let's see. Okay, you're using slice. Yeah. So the solution that I was saying is there a way without using the, again, it depends. The slice and everything, that's good. It depends on the interviewer. Sometimes they say, oh no, you don't use like any JavaScript function. Just do it like a I don't know, like a caveman do. Do it just using vanilla JavaScript. But I look at the slice one. That looks interesting. I'll have to. It takes me a while to understand what's going on. You have a couple of minutes. Just go over it. What's the slice thing doing? Like how are you solving this part?
I'm just using a for loop to determine your anchor A and anchor B, but I'm defining it so that like anchor A is always going to start with the second index. I don't need to start with the first index.
Nope. Okay.
Because that's going to be pointless.
Okay.
And then I'm also making sure that anchor B is never going to go past anchor A.
Yes.
And then anchor A is never going to be something like I'm constraining them.
Yes.
And then I'm just slicing the array. And then
So where is your anchor B? I heard anchor A. Where's the B?
anchor B starts at the array length minus 2.
Okay. So over here.
Yeah.
Okay.
And then it just moves.
So it goes here, right?
But they never, like, they always keep at least one value in between them.
Right.
If there's 0, then,
Oh, so this is okay if there's one value in between.
yeah, it'll always, it's always constrained, so that anchor B is always at least greater than the position anchor A is at plus.
Oh, okay. So you're reducing an iteration
Plus 1 plus 2.
going this way. You're just stopping it over here.
Yeah.
Okay. What about the slice one? That's the part I think. How are you using the slice?
Well, now that you have those, you can slice because you have the two positions, you just need to divide your array up into three parts.
In 3 parts, but what if it is like a not an odd array? It's going to be an even array. You can't really divide it in 3 parts. What do you
Well,
do?
you can, because it'll start at, if it's 6, then it'll start at 2 and at 5.
Okay.
And then it tries to go from there. Because even if it's even,
Yes.
you can still balance it if it's like 4, 2 and 2 and
Yeah.
4.
Yeah.
So it just kind of moves it, and then the next iteration you move the anchor B back in. The next iteration anchor the
Okay.
main loop would stop. Anchor A moves forward one, and anchor B restarts at the end.
Okay, I see. Yeah, it's kind of similar what we are doing over here, but now we have this power of slice, so it's kind of easier to slice those areas.
And then you just sum up your slices. and-
Yeah. So I'll post his solution also. But from the concept wise, what I understand is kind of still the similar part. You pick up 2 anchors, beginning and end, and you kind of loop through it. You kind of go through it and find a sum and do it. Again, these conditions are raised. I was thinking about the crossover. He's saying if there's only one in the middle, kind of stop over there. Again, those are the conditions you guys can figure out and make it more efficient. What Matt suggested, don't have to go through it also. But the crux was that this is how you kind of go through it. Okay. Remember this algorithm. A lot of questions, a lot of solutions are kind of centered around this pivot thing, pivot, drop, whatever you want to call it, anchor. They kind of usually, again, this comes with practice. So that's why I've done enough problems to kind of understand that, if they are saying this, then I need kind of some anchor points. Like I need to go through it. So that kind of helps. Yes.
I put in a random board. There's this game called 7 billion games. It's just a whole bunch of these weird programming puzzles. And
Okay.
in it, it's like you start using for loops and then you do weird operands.
Okay.
It gets hard, but it's just a bunch of these crazy puzzles.
Yeah.
And they were all fun.
Again, and this will come with the more you do it, the more this pivot thing. It's not this didn't reveal to me. I've seen some solution I've practiced more, and then every time I see something like this, my mind first goes, "Oh, can I use 2 anchor points and kind of loop through it, or what do I have to do?" Right? Instead of creating so many loops and kind of loop through it, that would be the inefficient solution, and that won't fly. So that's why these will come. Again, when I do some other, again, I do it in Java, so there's a concept with hash tables and all that stuff. So just as I said, the first answer is either JavaScript object or a callback function. For Java solutions, it's usually hash tables. So that's my first go-to. That every question I try to solve, like, oh, can I use a hash table over here? Because that's kind of makes it more efficient. Okay. In this case, since we don't have a hash table or anything, it's more like a pivot or some kind of this solution. Okay, again, I would highly recommend. This is a really good question. Please go ahead and give it a try on your own. I'll post the solution, and you guys can take a look at this. All right. Last chance. Do you want to exit out? I'm going to start Redux. If you don't want to get confused more, the React stuff, this is your chance. Otherwise, I'm going to start the theory of Redux. Right, who has looked at Redux documentation? Done anything? Okay,
A little bit.
a little bit. How did you find J?
Documentation
Oh, both are
is
J's, actually.
Kind of confusing.
Huh?
I feel like their documentation is kind of confusing, but I know
Yes.
it's like to share states across different components. So that's what I got out of it.
Right. He's right. The documentation is a little bit confusing. Again, if you read the documentation, they have said one thing. They have said that please do not use Redux just because you want to use Redux, right? They're saying they have special cases, and they had to add that because everybody saw React and Redux together, and everybody started using Redux, even though there was no use case. Okay, so I'm going to give you an overview, and kind of hopefully I can decode the documentation for you guys. Kind of makes you understand what actually is going on. Again, I have prepared this with a basic example. I have tried my best to make it as simple as possible. Again, Redux is not simple, so this actually might leave you confusing. Okay. All right, so this begins, what are we trying to solve? Then what is Redux trying to solve for us? Okay. Um, Before we start this, remember we have our app component, and then we have our, let's suppose, two more components over here. Okay. Now, how does our app component pass data down to A and B? Props. Excellent. All right. Now, what does each component have? States. Okay. Excellent. Now, if I want to communicate between them, is there a way I can do it in this condition? There's not, right? You can't pass state. States are local, and the props come down from the parent. Now, what was the solution for this case? If I do want to do it, right? You raise the state on the app. Excellent. You guys have been eating it. That's good. All right. So you raise the state on the parent one, and the parent then kind of passes the information down as props. Right, that's the solution. And if you are not using Redux, this is how you would do it. So on the screen, you see similar app. The use case where Redux is important is when your website, when your web page kind of gets bigger and bigger, and you're passing a lot of state between them. That case, it's fine. Most of the cases without Redux will work. In your project, I'm definitely sure it will work. Now look at this one. This is a web page. Starts from the app. And then there's, at the bottom, you see profile picture. I'm reusing components, right? In React, you can create components and you can reuse them. So I'm using my profile over here also and over here also. Okay. Now, this profile picture is kind of communicating with this also. It's a really nicely divided one. And, somebody followed the dry principle and they said, okay, I'm going to have many components. I'm going to divide everything in a component. So that's why you have a profile picture selector and a profile picture separate component, right? Now, if I want to communicate between these two states, what do I have to do? I have to put my state on my settings, right? Now, if I put my state in the settings, how does this get this data? As props, right? There's no other way. This is going to, the state is over here, it's going to pass down as props and props. So I change this one, and this one also gets changed. Right? Why? Because they both are the same. So this one is now expecting a prop as well. Right? It's the same code. Do you guys see it? It's the same component, same code. Right? So I change to make this work, I remove the state from here, I put the state over here, and it's going to expect a prop, it's going to work. And then this is going to work. But this is where it's going to fail. It's now expecting a prop down from my nav bar. My nav bar doesn't have state or anything. So this component works over here, but in your nav bar, your profile picture never shows up, probably some errors. Okay, so I still need to keep raising my state because it has to be available over here. So what do? The only option is keep going up. So I move my state over here. Okay, still this doesn't work. So I have to move my state over here. If I move my state over here, what happens? It is available here. It is available here. Right? So you keep moving your state up to the parent, up to the common parent. And what is the common parent of this and this? It's app. There's no other common parent. So you move your state up to over here. Okay, that's the solution without the Redux part. Now, what is the drawback of this? If this gets updated, this is going to get 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 updated, and then this is going to get updated. So every single component of your whole app is getting updated. Why? Because the state is over here. As soon as the state changes, what happens? Your component gets updated, right? If this gets updated, it's going to pass the props down because, hey, I'm updated. I'm going to pass the props down. I'm going to pass over here. I'm going to pass over here. If this gets updated, then this, then this, then this. So every single does this need to get updated? No. Does this? No, not really. About this? No. These are the only two components that you're updating. Why am I updating all the components? Right? And that's the drawback of, that's what Redux is trying to solve. Right? the only solution with React is you raise the state up to the common parent, and that's what we did. But the problem that it comes with is right now there are like 4 extra components. Let's suppose you have like 10 more components, right? Every single component is going to get updated. Why? Because everything comes from app. If your app has state, every single component is going to get updated every single time, even if you just want this one to be updated, or this one to be updated, or this one to be updated, right? So it's a trickle down effect. With a bigger website, it kind of becomes a problem, and that's what Redux comes in to kind of solve that problem. Okay.
So this is really one of the big advantages of React.
Of what?
One of the advantages of React is it's fast, and you're screwing that up.
Yes, exactly. Yep. Okay. Does everybody understand the problem? Does everybody understand the use case over here? Okay. Now, so that's why we need a state manager. Redux is basically a state manager. What Redux does is it says, hey, I'm going to manage your state. All right, I'm going to take care of all that stuff for you, and that's what basically Redux boils down to. It is just your state management tool. Okay, that's all Redux is. Okay, now is Redux the only thing in town? No, there are other tools. Same with state management. If you Google state management tools for React or standalone, you will find some more over there. There are like few. Redux is one of them, but there are few more that you can use. Redux is not the only thing. Okay. Now, but what happened over time is Redux has nothing to do with React. Like, if you look at the documentation, Redux is owned, was not owned, it's kind of open source, but it is maintained by a party that is not Facebook, it's separate, and somebody else came up with this thing, right? But this kind of blend in React so much that they kind of include it, and they created an NPM package called React Redux, right? But for state management in React, you don't need Redux. You can use anything you want, any different state management tool. But the documentation, and they have worked hard to kind of come up with a better solution, and they have come up with, because people were using Redux a lot with every React app, right? So they said, why don't we come up with the same solution, and we kind of merge them together and kind of give for this solution to people who want to use Redux in their React apps. So that's how they came about. But again, they both are independent. You can use Redux with your Angular apps. You can use Redux with your Vue apps. It doesn't matter. The documentations are separate. You will see there's a documentation for just React Redux, and then there's a documentation for just Redux. Okay? Again, it has nothing to do with React, but it became so popular. People were using it with React so much that they came up with another library, and they call it React Redux. Okay? But at the bottom line, what is Redux? It's state management. The screen that we saw, Redux kind of attempts to solve this problem. Okay, so that your every app component kind of gets updated. So that's when Redux steps in and they provide a solution to kind of manage that. All right, any questions before we move on? All right, this is the next checkpoint. If you are looking for the concept, this is what Redux is, right? The next part is, now we are going to get into the, well, not even coding part. We're going to get into the principles, but it is more technical now, okay? So if you are fine with this one, you can stop and you can leave. This is your other chance, because it's going to starts getting crazy after this, right? Because we saw what Redux is, we understand the concept, right? That is more important. But now how it does it, that's the next part. Okay? What is it?
Let's get weird.
Let's get weird? Okay. All right. So if you had to come up with a solution, what's the solution to manage this? And as her Blair said it, I think Joffrey also mentioned it in the previous classes, that if you want to manage state right now, every component has their own state, right? What's the better solution? Shared state, make a global state. Okay, if I can have a global store where all my states are, and then for example, if there's some state for my component A, and there are some states for my component B, they all reside in like a global store, global state store. Okay, but that store, and maybe there's another component that also requires a state, and all of this stored over here, and this component can only ask for the state that it requires, right? It has a state 1 that is stored over there, and this component has a state 2 that is stored over there, and this has a state 3, right? The problem without Redux is that everything is going to get updated, right? But in this case, if there was a method that, okay, this is my state S1, I'm going to store it. When I require, I only get the state this one. I don't care about anything else. Do I care? I don't care about this, I don't care about this. This component only cares about this. So when the time comes to get the state to get updated, this component can get only the state that it requires. Same over here. B can only get the state that it requires and ignore everything else. The advantage of this is everything else is never going to get updated. Only thing getting updated is this state. And this component is the only one that requires this state, so this is the only one that gets updated. That's the crux of Redux. We'll get into how this kind of comes together. So the three principles that your Redux is on, the first is called store. Okay. The second is called actions. And the third, the most confusing, is called reducers. Alright? You still have a chance to stop and walk away. Alright? I thought, I hope I was like joking, but this, and Jay looked at it, Jay also looked at it, the documentation is not easy. But again, these are the three main things when you talk about Redux: the store, actions, and reducers. Okay? Now, store is the global store that I talked about, right? The store is the one that houses all the states of your app. Every single state is housed in the store. Okay? Now, if it is in the store, there has to be some kind of, how do you retrieve from it? Right? I'm storing everything in my store. How do I retrieve from it? That's where the second part comes in. Actions. So Redux has something called actions, and these are the actions that kind of retrieve or kind of update the store. Okay? Now, actions, you can kind of say they are more like events also. Like something happens, that's when your store needs to get updated. Okay? For example, I'll do a counter app. So if my counter goes up, I increment my counter. It's an action. I'm increasing it, right? Now my state has to be updated because my state has gone +1 or decrement -1. So my state changed, right? So my actions are going to fire and then say what happened. Did my increment action fired or my decrement action fired? Then the store is going to do something and kind of update its state based on those actions. Okay? Now these actions, when we go into the code part, you will see these are just like JavaScript objects. They don't do anything. They're just like informing. The part that actually acts on those actions is called the reducers. These are the functions that actually go ahead and act upon that action, and based on that action will actually update your store. Okay? Again, actions are generated. If I'm talking about this, right, there are some actions that kind of go ahead and update the state. They kind of inform your whole app that something happened, state change. Now my store, my global store needs to be updated with a new state, right? And reducers are actually the one that has the code that will update the state, update the new state. Okay? Now, with that logic, where do these actions originate from? Like who, from your React app, what part are these actions originating from? Excellent. Components. You guys see it? The natural progression. There's only one way that these actions will be fired from. These are going to be fired from your component because the components are the ones that are doing something, right? So your actions originate from your components. Okay?
Are they defined in the components? Or
They are not defined in the component. They just originate from a component. Those actions, all these three things are independent. They kind of defined separately, but these kind of originate from actions, and then actions kind of call those reducers. That reducers know what to do with that new thing. I want to update my counter. Okay, the reducer will do it, and then your store kind of gets updated with that.
So the actions aren't actually doing anything, they
No.
just trigger the reducers.
Exactly. Yep, they are not doing anything, but they are important part of this. If you take the actions out, there's no communication. Nobody knows what's going on. Actions is what alerts your app. Oh, hey, the state changed. Now I have to do something, right? But they don't know what to do. They don't know how to do it. All they know is that something happened, and they pass on to reducers, and they say, hey, something happened. Take care of it. Okay, reducers are the one that kind of do something based on actions. So if that is the case, if I'm looking at the code, what would you see over here? There can be multiple actions, right, that are being fired. My reducer is going to have what kind of a data structure over here?
You're gonna
Around
pass
function.
an action and a state as an argument, right?
Yeah, that's okay. But if I get some action over here, what am I doing in my reducer over here? Like, how do I know which action got
like an
passed?
array of functions?
You're,
Not a
it's
function.
a function that produces a brand new state, right?
Right. No, that's okay. But within the code, if let's suppose I have like 3 actions, right? Now in my reducer, how am I checking which action, what to do on what action? What's the condition that I use? If I have multiple actions coming in,
Props?
it's a simple.
Component did not?
No. Again, it's we are too advanced. I'm talking about. So I have action 1 coming in, right? And then I have action 2 coming in, action 3. Right? There you go. Who said that?
Oh.
Right? So basically, a drop-down is just a switch statement. These reducers are not complicated. All this has is an if or a switch statement. Say, oh, if this is do this. If this is this, do this. Simple. That's all. I'm kind of now we are getting to that part. But before getting to the part, I want you guys to be not scared. Basically, reducers just have your switch statement or if statement that actually say, oh, if this action is fired, do this. If this is there, do this. If this is there, do this. Do something. And we'll see what it is. But that's all your reducers are. Okay? Questions? Everybody getting it? So far so good. No, this is good. If you are getting that, that's the code again will follow naturally when you see it. But the concept is so if you can have this diagram in your mind when you are coding, it makes it a little bit more easier to see how the communication is working. Okay. Now with that concept, how many stores can I have in an app? One, right? It's logical. I mean, if I have 2, it defeats the purpose. I don't know which store to go to. So Redux kind of puts that kind of enforcement over there. Usually, we'll start with just one reducer. Okay, I will tell you that you can have multiple reducers also, but in our app, usually you will see that there's one reducer that kind of takes care of your all actions. And the purpose is they're saying that your app only needs so much actions, right? If I have let's suppose I'm going to make an app, a counter app, which increases or decreases based on plus or minus, right? How many actions can I have? I can only have 2 actions, right? And they kind of go together. That's why in this case we'll have one reducer. But if your app is big, that's where Redux comes in. You can have multiple reducers, which have, if I have multiple reducer, what does this tell me? So my reducer are tied to my actions, right? And I have a switch statement over there. So if I have increment and decrement, I'm going to say, oh, if increment action fired, do this. If the decrement action fired, do this. So that goes in my reducer. Now, if I have more than one reducer, what is that telling me?
More than one action.
More than one actions, right? That are independent of each other. Now, increment, decrement over here kind of go together, but there might be a case when my app gets bigger. There might be a case when my actions are What are possible? Something with daytime. Maybe my time goes up and down. Time in seconds goes up. Time in second goes down. Let's suppose I have a counter or something, right? So these kind of don't relate to increment and decrement, right? These are suppose in a separate component. So in this case, I would have a different reducer, and those actions will be residing in that reducer. Okay. We'll see example with one reducer, but you will see that as your app grows bigger, it's probably a good idea to make more than one reducers. And then your store has a way to like combine all those reduce, and we will see. That's like the bonus part or like the advanced part. But I just wanted to. Usually, you can get by just with one reducer, and it's still okay. Okay, and I'm saying this because people came up. It's a good progression because when you look at the code, they're like, well, my reducer is kind of getting bigger, right? And my actions don't actually correlate with that. Can I break it down and make it more reducers? Yes, yes, you can. Okay. All right. Let's see. All right, these are more too much. We'll come back to this. All right, the first thing is we talked about the store. Let's talk about actions. Actions, what did I say actions were? Just objects. That's what those actions are. When you define an action, you are basically in the code you are defining a JavaScript object. When I talk about object, it means this thing. Okay, that's all an action is. Now, action in that object has one mandatory property called type. Okay, this has to exist in your action object, whatever object you create. Okay, for example, if I'm creating a action called increment, then I have to define what's the type of this action. The type is increment. Okay, and then optional you can have whatever you want. It doesn't matter. Usually, what it is, it's called payload, or you will hear some different words, and we will get to it. Right? Don't worry about the ones that are optional. The important part is an action needs to have a type. This defines what's the type of this action. Is it increment? If it's a decrement action, then you have a type called decrement. This is just a string. You can put anything you want to it. That makes
So
more logical
is the
sense.
type what's passed to the reducer in the switch statement?
Exactly. That's what. Actually, you guys see what he said. So based on this type, you see the switch statement that we're talking about, and that's how the reducer says. So it says action dot type. What is the type of this action? Then I'm going to execute this code. What is the type of this action? Then I'm going to execute this code. That's what gets passed. Yes.
What's the advantage of the bringing of a separation of actions?
Again, the example that we will see there, you won't see any advantage, but again, it's the same thing. You're kind of making it more dry. You're keeping your actions separate. So if you want to add an action, you have a file structure over there. You will just add one action over there, and there's no like a major code changes over there. All you will have to do is just update your reducer, and your action is already in motion. It's more like a dry principle versus more like what are the coding. If it's going to make it more efficient, it's not going to do anything. Okay. Let's see. All right. Everybody clear on the store actions? Action JavaScript. Reducers. Reducers are pure functions. Somebody remember what pure functions are? Remember from the React class, I don't know, day 2, we talked about pure functions. What is it?
I just read about
It's more like a concept. So basically, pure functions are the functions that do not modify the input. Okay. For example, if I have a function that adds two numbers, num1, num2. Okay. And then I say return num1 plus num2. Is it modifying the input?
No.
No, right? So this is a pure function. Now if I do this, num1 is equal to let's do plus equal to num2, and then return num1. Is it modifying the input? Yes, because my input is num1 and it changes the value of num1. So this is not a pure function. Pure functions are one that do not modify whatever you get passed in. Yes, you get a new value, but they are not touching, they are not updating, they are not doing this. Instead, they are creating a new variable and then returning a new variable back to you. That's what pure functions are. They do not modify your input. Okay. Now, when I talk about reducers, reducers are pure functions. It means that whatever you get passed into your reducer, that doesn't change. You get a new value back, but the input that you pass in, that's not getting changed. You will see what reducer, what are the inputs. Jay mentioned actions and state and actions when it comes to reducers. We'll see how those are not changing. But remember, reducer are pure function. This means that whatever you get in your reducer, that always stays the same. You're going to get a new value back, but your input is not going to change. So those are called pure functions. What about high order functions? Anybody know what high order functions are? HOC, you might have seen in Redux to talk about it. So high order functions are functions that take an input on other functions. For example, callback functions, right? Or if a function returns another function, that's also called a high order function. Okay, two things. If they take input as another functions, or the return, which is another function. Those are basically called high order functions. So you will see this word, and if you get confused, those are the two definitions. Okay? So we'll take lunch. We'll start back at 12:45, 12:50, and then we'll go a little bit deeper with Redux stuff. Okay, but this covers your basic Redux from the concept wise, what you need. The next part is mostly now coding this out. Like, what are these? What do these actually mean?
More files.
What is it?
I said more files.
More files. Yes. What is it?
The Redux example.
Makes sense.
As you talk through it, it makes sense to follow the files.
Right. That's why I kind of started like that, so that it kind of organically, yeah, there you go. Kind of comes into that motion. If I just start showing you the code and the counter example, wouldn't make sense.
It's overwhelming.
It's overwhelming already, yeah. But this is how these are, and we'll see how to code each component. Each of these will be coded out.